All right, there you go. So if you got 3 standard deviation away from the mean, you got 2.35%. So 34 plus 13.5 plus 2.35 is 3 standard deviation away from the mean. And this is approximately 0.15 if you have 4. Um, approximately this whole thing, the curve, is going to be equal to 1. Approximately 1. Could be close, could be over, but it's going to be approximately 1. All right. So the area under a normal curve. Suppose that a random variable x is normally distributed with mean and standard deviation. The area under the normal curve for any interval of values of the random variable x represents either the proportion of the population with a characteristic described by the interval of values or the probability. So the area may represent probability as well. So when we say area, sometimes the question will ask you find the area uh, within that normal curve. It also means to find the probability. So probability and area are interchangeable when you're being asked for that particular question. All right, so suppose the random variable x is normally distributed with the mean and standard deviation, then z is your data x minus mean divided by standard deviation. You remember your z-score, right, from the previous weeks?
Yeah.
All right. We're going to use the z-score because sometimes we're going to find how far is your data from your mean. All right, so the standard normal curve has a mean of 0 and standard deviation of 1. To find the area to the left of the specified z-score, which is also the area to the left of the right, or the value of x in the distribution. So for example, if we take an example on IQ scores, so IQ scores can be modeled by a normal distribution with mean equals 100 and standard deviation equals 15. An individual whose IQ score is 120 is 1.33 standard deviations above the mean. So you know it's above because it's positive. So that means that person who has 120 IQ score, if the mean is 100, so it's going to be 1.33 above that average. So the area, if the question will ask you find the area of area because we're talking about person. So the area under the standard normal curve to the left of z is 1.33. So the area is 0.9082. So right here is 0.90, this shaded region right here. Now, to find the area, which is what we're looking for, this is 90.82, this big area right here, the shaded one. And then to find the area, the other side, we're going to use the complement rule to find this right side. So when we say complement rule, since the whole thing is equal to 1, and this is already given, the shaded part is already given. So we're just going to subtract 0.9082 from 1 to get the side of the bell curve, which is going to be 0.0918 or 9.18%. All right. All right. So having said that, let's go ahead and deal with the question in your homework, which is this one. I don't know if because I randomly I opened it up, the homework, and since there's like 20 several questions with similar problems, I'm not sure if this is going to be exactly what your homework is. like the numbers. I think when I generate another version, it's giving me different numbers, but it's gonna be similar, right? So if you have the same or exact numbers, lucky. If not, you can just take notes and see what how can we answer this type of question. Is there anyone here who have the same numbers for the homework? I got the first one. Find each probabilities where z is a z-score, standard normal distribution with mean of 0 and standard deviation of 1, round to four decimal places if necessary. So, is there anyone here with the same numbers in the homework?
Mine are different.
You got the same?
Oh, mine are different.
Those are different. All right, that's good.
Mine are different too.
It's gonna be the same procedure. It's just different numbers because the version when I was looking at the homework, when I generate another version, it gave me these different numbers. All right. So let's see. You got probability when your z-score is less than 1.64. Um, do you have a scientific calculator? So we can use the sign calculator to find this when your z is less than 1.64. That means when when you look, pay attention to that symbol less than, that means we're looking at the area to the left of that z-score. So it's 1.64. Let me see if I can share a calculator here. All right, I don't think I have calculator. I can't share my calculator, but if you have your calculator on hand, so here's what you're gonna do. So I'm just gonna write here. I'm gonna share a blank whiteboard. So the problem was the mean is that problem. The mean is equal to 0. Standard deviation is equal to 1. Can you see my whiteboard?
I can see it.
All right, thank you. And then in your calculator, depending on what calculator you have, some already have the lower limit. If you don't have the lower limit on the calculator, you can just put in -9, five five nines, but it's negative. So you're gonna put in. I'm gonna put here second vars so that you can have. So press the second vars, right? And then after that, you choose number 2, which is in my end, I have normal CDF. Now, if your calculator already have that lower limit, some will have like -1 E99. Some will have -9999. This is just like a random number. That's the big lower number. So some of you will have this, some of you will have that, right? And then for the upper limit, you're gonna put um, the z-score that we have that was given, which is um, what was that? That's 1.64. So you're gonna put the z-score that's given, that's 1.64, and then check your mean is actually equal to 0, and then your standard deviation is actually 1. And then you just press enter. like here, this probability of z is less than 1.64. And then I ended up having, in this scenario, if my z is less than 1.64, I ended up having 0.9495. Now, since this is the left, we don't have to use the complement rule. So if the symbol is less than, so your answer is going to be, it is what it is, so 0.945. All right, got it? Are we good on this one?
I'm good, thank you.
All right, great. All right, so next question, let me see. The next one, the probability of z is greater than, I don't know if you can see. The next one is probability of z is greater than 2.78. So it's going to be my A. My B is the probability of my z is greater than 2.68. So you just basically gonna follow the same procedure, second vars, then normal CDF. Check your lower and upper, your standard deviation, and your mean. But whatever you get here, make sure you use the complement rule, because this and right here, the symbol means we are looking on the area or the probability on the right. So let's go ahead and try that. So second vars, you have lower is negative 999,999. Your mean is 0. Your standard deviation is 1. Uh, what do we get here? I have 0.9973. So when you get this answer, since this is greater than, that means we're going to use the complement rule. This is the left. We're trying to find the right side, the area on the right side. So you'll take your answer minus 0.9973, which is equivalent to 0.0027. All right. Question on this? Very good.
I'm good.
All right. Thank you. I'm gonna have to erase the whiteboard so that I'll create more space. Okay. So the next question is, what is that? Find the probability if your z-score is between 0 and 0.37. So you might have different numbers there, but the next one is letter C. Probability and your z-score is between 0 and, what do I have here? 0.37. All right, so in this case, you have two, your z-score is given, to the upper and the lower is given already. So when you press your second vars, your calculator, you're just gonna have to replace your lower limit instead of negative 999 or negative 1 e raised to the fifth or seventh power. You're just gonna replace your lower limit to 0, and then the upper limit replace with the 0.37. And then you keep your mean, which is 0, and then standard deviation, which is 1. Let me check. Second bar is normal CDF, lower is 0, upper is 0.37. So I got here 0.1443. All right, that's letter C. Letter D is the same thing. Letter D is the same thing, right? All right, let's go back to the screen. All right, so this one. So letter D, the z-score is between negative 2.58 and negative 1.25. So similar process to the previous one. So that's what you're gonna do with that one. All right. Um, next is this question. So again, I generated a question. So I got this: find the z-score such that the area under the standard normal curve to its left is 0.0228. So what's the plan here? The plan is, since the z-score is missing, yeah, which is 0.0288. Uh, illustrate this. This area is on the left side of the bell curve. To is far x-axis left of the mean. So when z-score is missing, I'm gonna write it here. Okay, when z-score is missing, let's write it here. The z-score is missing given the area. So given our scenario is 288. Remember, yeah, 0.0288. That's the given area. So missing z-score. So what you're gonna do, what you're gonna press in your calculator is second vars. All right, and then you're gonna choose number 3, which is the inverse norm, because this time the z-score is missing, not the other previous problems. Is a normal CDF. So this one z-score is missing. You're gonna choose number 3, which is the inverse norm, and then you're gonna enter the area given, which is 0.0288 on my example. Keep your mean, which is 0. Your standard deviation is 1. And then you choose the tail to the left. Problems that we have in our homework is to the left. So make sure the left is highlighted.
Thank you.
So what we have here, what's our answer? Let me try my calculator. The second vars, number 3, just number 3, inverse norm. Area is 0.0288. 01 to the left. And then so I got here negative 1.8987. Got it?
Got it.
Okay. Let's see. This problem right here, the next one, let me share you again my presentation. Okay, here. Okay. So the management of a supermarket wants to adopt a new policy of giving a free gift to every customer who spends more than a certain amount per visit to the supermarket. The expectation of the management is that after this promotional policy is advertised, the expenditures for all customers at this supermarket will be normally distributed with a mean of 78 and a standard deviation of 18. Um, Management's assumptions are correct. What percent of customers will spend $67 or less? Again, uh, percent, area, probability, they are interchangeable. This is talking about still the area in the normal curve. Okay, so it's still normal curve. As it says here, spend 67 or less. So to in symbol, I'm gonna keep it the mean is 78, their deviation is 18. I'm gonna share my whiteboard, okay? So my mean is 78, standard deviation is 18. It's asking for um, what percent of customers will $67 or less. I'm gonna put here $67 or less. So writing this in symbol, we can write this as the probability or the percent of this customer spent $67 or less. All right. First question is enter the z-score for your calculation, right? That's the first question in your homework. Enter the z-score. You know the z-score from the formula. Find it. Z is equal to the variable minus the mean over the standard deviation. So your mean given is 67 minus your mean, which is 78, over your standard deviation, which is 18. I'm going to have negative 0.1. Right?
Yes.
Okay. Right. So that's how you get the z-score. Next question, I think part B. Let me see. I'm flipping back and forth on my whiteboard and my presentation. So that's letter A. Enter the z. Now enter the percent of customers who spend $67 or less here. So, so the same thing that we did in our first three problems. What we're gonna do is again. So again, the mean is 78. The standard deviation is 18. So we look at the percent of 67 or less. So the probability of your customers that spend 67 or less. So I use that symbol. Now you're gonna go to second vars, then this is the normal PDF, and then you'll have that lower link again. Second vars, normal CDF. Um, the upper limit here, so your lower, same thing. The negative 999 or the one negative 1.1 raised to 99. The upper is going to be the 67. You can see here. And then this time, you have to change your mean, which is 78. You get to change your mean. Standard deviation is 18. So I have here 2706. And since we're looking for the percent, or changes the percent becomes 7.06%. Right?
Yeah.
Right. Question. Part B. Go back here. So we have this already. So the percent of customers that will spend, we have that, which is 27.06. Okay, for part B, round the Z value to three decimal places and enter percentages in percent form. It is 3%. That's the rule, how do you round your answer. If the management wants to give free gifts to at most 4% of the customers, what should the amount be above which a customer will receive a free gift? Okay. Okay. Enter the Z value for your calculations and then enter the amount above which a customer would receive a free gift. Okay. All right. So first, the problem is you only want about 4%. You want to give gifts to the customer who spend above 4% of the amount of they shop, right? You are looking at customers who spend a certain amount more than the mean. First, we need to find the z-score for an area to the right of that z-score, which is, since this is 4%, so let's change that to, treat that as our area of the curve. So change your given percent, right? It will be 0.0, and this is going to be the area um, to the right. So because this is the area to the right, um, and we find the z-score, we're gonna use the complement rule. And area to the right. It is to the right because we're looking for the amount for customer more than mean. So more than the mean, that's gonna be on the right side of the curve. So the z-score, what information do we have here? So that's the area already, 0.04. So use the complement area, complement rule. So you have 1 minus that given 0.04. All right. Point 96. Now, since we're looking for the z-score, we're going to use the inverse norm to find this. Use the inverse norm. The second var's inverse norm. When we use the inverse norm, the area that we're going to put the 0.96. And then your standard deviation is going to be 0. I mean, your mean is 0. Your standard deviation is 1. So, and then press enter. Your z-score is going to be 1. So the tail should be on the left. So I have here 1.75.
Yes.
All right, that's going to be the z-score. Now to find the row score or the amount more than the mean. So this is what we're looking for. The amount more than the mean. Use the inverse norm. And then put the area, which is 9. And then the mean, the mean given, which is 78 in the problem. And standard deviation is 18. For the first one, the mean is 0, the standard deviation is 1. You need to get the z-score. You need to get the amount more than the mean. We will actually use the given mean and the standard deviation, right? So do the same process. It's still left side and the amount receive a gift. You get
The 109.51.
yes. So who spent $109.51 dollars? These are the people who will receive a gift. All right.
Got it.
Right. So I know this is one of the hardest part. So the first, change your percent to decimal, then use the complement rule, and use that area z-score to find the. Then you should be able to find the z-score, and to find the actual amount to receive a gift. Same area as 0.96. Change your mean and the standard deviation. Right.
Sounds good.
Okay. Next one. Let's see. one. Okay, the results of the latest writing on of the LSAT, the Lost Schools Aptitude Test, showed results that were normally distributed with a mean score of 876 and a standard deviation of 50. So what percent or enter percentage answers in percent? Okay, so let's go. Okay, so what percent of students scored between 795 and 959? So this is very similar to the first few problems that we did. So you can write in symbols probability of, fortunately I can't write in this one. We can write this, um, so you can write probability of 795 and z less than 955. You know what I mean? You know what I'm saying? Just yeah. 795 and 959. I'm gonna do that. It's between 790 and 959. We have the mean given. The example is 76. Standard deviation is 50. So right symbols, the probability of 795 for your z score, 795 and 959. The second bars, the normal PDF, upper or lower. Lower is the 795, the upper is 959. Just change that. Then don't forget to your mean and standard deviation given. For the lower, I have 795, then 959, 6, standard deviation is 50. I'll look at my calculator. Upper is 9, yeah, 50. I got 89 or 0.8989,
Sounds good.
89.89%. Okay. Um, Next question. We answered B8, right? B, what percent of students got 986 or more on the test? So this is when you write in symbols, you have probability of z greater than 986. So I'm gonna put here. So because it's more than, it says more than, or 986 or more. So symbols, that's gonna be the probability of or greater or more than 986. So the same thing. Here's um, um, the PDF, and then um, Go back to the problem. 76 mean and standard deviation of 50. So what do we have? I have 0.922. You get the thing.
What did you put as the lower and the upper? Sorry, I missed that part.
So use for the lower, I have the negative 999. Double check. Wait. That's the problem. What is the problem for me? Alright. So what's the lower?
So what are you putting as the upper?
For the lower, I put the negative one. If you have the negative one E999 or the negative 999, the upper is the 896.
986 or 896?
986. So I have 86. Is it 986? Let me check my data. Yeah, it's like 896. Oh,
896?
986. 986.
Okay. Uh, 876 was the mean, and 50 for the standard deviation. I'm getting 0.986.
So am I.
Yeah, me too. I'm gonna have to check that. I got 0.986091. 986.1. Okay. But this is greater than. So don't forget to subtract 1. So 1 minus your area, that's 0.9861. Because you have to use the complement rule. So we have 1 minus 0.9861. We have 0.0139 or 1.39%.
Got it.
All right. The next part of the question. Next part is all. Let me read this. Yeah. Would all law school wants candidates for admission to be in the top 8% of the test score. What is the minimum test score needs to achieve to be considered for admission to this? So you look for top 8%. So this is similar to what we just did in the supermarket earlier. So we're looking for top 8%. Let's maybe blank screen. So top 8%. So this is what we're looking for. Let me just write the information earlier. Data. So the mean is the standard deviation is 50. All right. So our step earlier in the supermarket, we changed this to decimal. So 8%. Change it to decimal. That's going to be 0.08. And this is going to be your area. And since we're looking for the top, that's going to be on the right of the normal curve. So we're using the complement rule. So we have 1 minus 0.08, and we'll get 0.92. Okay. And we don't need the z-score, right? So we always need the top 8%. So we're keeping the z-score. We are going to use the first norm, so second vars, inverse norm. Put area is going to be 0.92. Mean is 876. Deviation is 50. Second vars, inverse. Yeah,
946.25.
that's right. So we got 946.25. This is the score that they will admit in that school they're looking for. All right.
Got it.
Okay.
So the only time inverse norm is ever used is not when you're using a z-score, correct?
Correct. Uh-huh. All right. So next question. Let me see. Part D. So for part D, enter probability answers in decimal. Okay. So if a group of 53 applicants is randomly selected, what is the probability that the group average is not less than 896? So this is combination of central the formula for the central limit theorem was given. So I'm just gonna have to remember. So if a group of 53 applicants is randomly selected, so that applicants 53, and then we're looking for 896. So six standard deviation 50. Right. So that one we're gonna use formula v equals given minus mu or standard deviation over the square root of n. In your n is the random or that we have the 53.
Yeah, I should have been passed out at that point. That's what the doctor said, so I was lucky.
So this is your data that's given, the given data in the problem. In our problem, In the case we have less than 896. The number here, that and then we know our mean is 10, and then standard deviation is 50. It could be the n is the random sample or the sample size that's given. Problem, we got 53. So we're going to use this formula to calculate that. So since it's asking for, I think, more than 8, so in symbols, the probability of your uh, variable z or your variable is greater than 896. So we're not going to use the calculator here. We're going to use this formula because we have the sample size. So just plug in z is equal to, get 896 minus 0.76 where standard deviation 50 divided by the square root of your sample size, which is 53. All right. So what do we have here? Let me see. 896. 20 over 686. Got it. The first part of the question, right? Let me double. Okay. So this is gonna be the. Let's treat this as our upper z-score. So upper z. This is gonna be. Your next step is to do the second bars. Well, CDF. The lower, you keep your lower, which is the negative 999. Upper, gonna be your upper. What we just computed is 2.91. The mean is going to be 0 because we're using the standard normal curve. We already used this earlier. Then the standard deviation is 1. So what did we get here? Second bar.
0.82.
Mhm. Okay, now, so we have this, but since this is more than, right? The problem is looking for more than, so we're going to use the complement rule. So you have 1 minus 0.9982, which equals 0.008, I mean 18. Last one is so low. Okay, all right. Next question. We just answered letter B, right? Okay, what's next? Is what percent of students scored between 739 and 955? You know how to do this, right? So in symbols, you're just gonna put uh, second vars, lower limit is 739, upper is 955 because it's between.
And then you put the mean at 851 and standard 70.
Correct.
.876.
Right. A percent, you change that to percent, so 87.6%
87.5%, yes.
students got 1,007 or more on the test. So in symbols, that's gonna be Z, probability of Z greater than 1,007. So same thing. So second vars, normal CDF, lower is the -1 E99 or -9999. The upper is the 1007, 1007. And the mean is 851 and standard deviation is 70. You end up having
The answer would be 1.29%.
that's right. Because don't forget the complement rule because if it is it's greater than, right? All right. So that's you're good with that. Slide 15. Okay. That's the same thing, right? So if the management assumptions are correct, so this is similar to the supermarket problem, right?
Yeah.
Okay. You have to get the Z score. Um,
We have
7,
2 minus 98 over 17.
that's right. Got negative 1 point something, 52 or 53. Right. And then letter B. Wait.
1.3, yes.
Okay. So, so when you're doing your homework, if it's giving you an incorrect answer because you didn't match the decimal place or decimal points, please know that I'm manually checking it, like going over your answers and then giving you points if if your answer is really close. All right.
Okay.
All right. So enter the percent of customers that will spend $72 or less. So in symbols, that's going to be probability of Z less than 72. The second normal CDF. Your lower is the negative 199 or the negative 999. This one, the upper is going to be 72. And then your mean is 98. Standard deviation. Right? What do we have?
6.1%.
That's right. And then the between, what percent of customers will spend between $72 and $110? The second bars, normal CDF, then the lower is gonna be 72, and then the upper is 110. And then you have your mean and standard deviation.
You have 9.68%.
Correct. 9.68. That's right. All right, let's see the next question. Okay, so if the management wants to give free gifts to at most 2% of the customers, what should the amount be above which a customer would receive a free gift? First, you're going to calculate the Z-score. So what do we use here to get the Z-score?
You got to change the 2% to 0.02.
That's right.
Take away the mean, which is what, 98?
0.98.
Divided by the standard deviation.
No, wait, for the Z-score?
Oops.
So we are going to use the inverse norm, remember?
Okay.
So after you subtract 0.02 to 1, so you end up having 0.98, right? So that's going to be the area. So inverse norm, so second verse inverse norm, then area is 0.98. Since you are looking for the Z-score, we're going to use the mean as 0 and standard deviation as 1. You follow that, or do you want me to write it down?
Inverse norm, and then the lower is
If
negative.
the area is 0.98, if you use the inverse norm, I don't think it's going to add.
Okay, you don't need the upper or lower.
Yeah, over if you have to use the inverse norm.
Okay,
You're going to have the area. It's going to ask you the area, which is the 0.98.
gotcha.
And then, so 2%, I would say, I'm just going to write it. So most 2%. That to decimal 0.02. And then subtract that from 1. So it will give you 0.98. Then second vars. Inverse. Inverse norm, it's going to ask you for area.
And it's 0.98, correct?
Yes.
And then 98.
Because we're looking for the Z
Oh,
score.
yeah, sorry. 0 or 0 and then 1.
0 and 1. We have here, I got 0.05.
Yes.
Now the actual amount looking for. This is the time that you're going to use the given information, the mean 98 and standard deviation 17. So second vars inverse norm area 8, 98. Um, the mean is 98. That was the given, right? And standard deviation 17. I have here 30.91. Okay, so let's see the next one. Mhm. All right, the next one is, we answered this already, right? No, this one. So the amount was 132.31.
Yes.
Okay. This one for part D, round values to two decimal places, use the central limit theorem formula. If a group of 57 applicants, so this is going to be our sample size. This is going to be the N. So 57 applicants is randomly selected. What is the probability that the group average is not less than 92? So your X bar is going to be 92. And then your mean is, oh, what's our mean here?
98.
98 divided by standard deviation, I think 17, and divided by the square root of 57. You all do that in a calculator.
For the data for the X, did you use 0.92 or just 92?
No, it's 92. So we have, yeah, because it says less than 92, so that's the data, the X bar. 92 is our X bar.
92 minus 98. Is it negative 2.66?
That's right. 0.66 is the Z-score. And then for part E, the probability that the group average is greater than 92. So, so when you write it in symbols, that's going to be probability of your X greater than 92. So we can use X or the Z if you would like to. If you would like to stick with the Z, so it's greater than 92. So you can do the same thing. So second vars, normal CDF. The lower is going to be the negative 9999, and then the upper is the negative 2.66 that we got the Z score. And then we're using the mean and standard deviation in a normal curve. So that's going to be 0 and 1.
I got an error.
Let me see.
But inverse norm negative 99999. And then the z-score of negative 2.66. And then 0 for the mean and 1 for the standard deviation.
Mm-hmm. So you're not going to inverse norm, you're going to second vars normal CDF.
Okay, that's why I'm hitting norm.
So you're using normal CDF, the lower is the negative 999, upper is the z-score that we calculated, 2.66. Then you keep the 0 and 1 for your standard deviation and mean. So you end up having, I got 0.003 or 39. What you
0.0039, yes.
got? And then since this is greater than, right? So you have to get the complement. I think I should write that down. This is letter E, right?
Yes.
All right. Down so that you know if you want to use the notes. What we did is first we used the formula for the z-score. Then we ended up having negative 2.66, right? But the question is asking for greater than 92, right? So second vars, we did second vars, normal CDF. And then the lower is negative 999, or is the one that we calculated negative 2.66. The mean is 0, standard deviation is. And then having, what do we have here? 0.0039. And because this is greater than, we use the complement rule. So you have 1 minus 0.0039, which is equal to 0.9961. All right. So that question letter E has a probability that the group average is greater than 92. That was 99.61%. Okay, next slide. Oh, this is a lot. The same thing, right? You're just using that. With this,
What's that?
are you good with this page? Be a lot. This
Yeah,
is
I
gonna
think
be the same.
Yeah, I got that page.
All right, great. It's 19. All right, so the patient recovery time for a particular surgical procedure is normally distributed with a mean of 5.3 days and standard deviation of 1.8 days. Use the cumulative z-score table. So it's the same thing. So what's the probability of spending less than? So the first one should be the probability of, z less than 0.26. You know how to do that, right?
Yeah.
This one also, so this is more than, so that don't forget to use the complement rule for this because this is more than the probability of your z greater than 4.85. So don't forget to use the complement rule. This one the probability of spending between 3.86 and 8.18. So change your lower limit to 3.86, then your upper to 8.18, right? Okay. Okay, so it's the same thing for greater than, so just use those symbols. Greater than, don't forget to use the complement rule. All right. Okay. All right. So that's week number 8. We have week number 9. So week number 9, you still want to keep going? So this is your assignment, your homework for this week, chapter 8, sampling distributions. So the learning objective for this week is to describe the distribution of the sample mean or normal population. So when you click this, I don't know if you want, let me see if I can share this to the chat so that you have the link. I put the link also in our My Open Math or and in the Blackboard. I have to do that in the Blackboard too. But these links are in My Open Math. So if I'm gonna click this one, it will take you to the video that will explain about the sampling distribution. Okay. You can watch it.
Now that we have explored the behavior of the sampling distribution of the sample mean using the online
Can you tell me if you're seeing the video or just my presentation?
It's the video, but it's right.
interactive applet, let's look at some more specifics. So suppose we have some population parameter that has a distribution with mean mu and standard deviation sigma. Then suppose we take a random sample of size n from that population.
There's
From
no
that,
video.
calculate sample.
Okay, it's not working properly. There you go.
Then we take another random sample. Applet. Let's look at some more specifics. So suppose we have some population parameter that has a distribution with mean mu and standard deviation sigma. Then suppose we take a random sample of size n from that population. From that sample, we calculate sample mean x bar. Then we take another random sample of the same size n, and we calculate the sample mean of that random sample. Then we take another sample of size n from the population, and again we calculate the sample mean. Suppose I can continue this process indefinitely and get a whole bunch of sample means from random samples of size n. Now, since there is variability from one sample to the next, there will be variability among all of these sample means. It makes sense that we will get different sample means from different samples. If we take all of the samples of some size n from this population with mean mu and standard deviation sigma, and we put all of the sample means together, we get what is called the sampling distribution of the sample mean, x bar. It turns out that this distribution of sample means has the same mean mu that the population has, but it doesn't have the same standard deviation. The standard deviation of the distribution of sample means is equal to the standard deviation of the population, sigma, divided by the square root of the sample size, n. Notice that since we are dividing the population standard deviation by the square root of the sample size, as the sample size increases, the standard deviation of the sample distribution decreases. Let's write this a bit more formally with some statistical notation. Let x bar be the mean of a random sample of size n from a population having mean mu and standard deviation sigma. Then the mean, denoted mu sub x bar, and the standard deviation, denoted sigma sub x bar, of the sampling distribution of x bar are mu sub x bar equals mu that is the mean of the sampling distribution of x bar, is equal to the mean of the population, and sigma sub x bar is equal to sigma divided by the square root of n. So in other words, the standard deviation of x bar is equal to the standard deviation of the population divided by the square root of the sample size. Note that the standard deviation is exact if the population is infinite and approximately correct if the population is finite and the sample size is no more than 10% of the entire population. So we talked about the mean and the standard deviation of the sampling distribution. What about the shape of the sampling distribution? To answer this question, we will look at two different scenarios. The first is when the original population is normally distributed. We have a normally distributed population with mean mu and standard deviation sigma. We take every possible sample of size n. This sample size can be any number at all, but every time we sample, we stick with the same sample size as before. Then we calculate the sample mean for each of these samples. When we put all of these sample means together, we get the sampling distribution of x bar. Since the original population was normally distributed, regardless of what sample size we used, the distribution of all of the sample means will also be normally distributed. And as we mentioned before, the sampling distribution will have mean mu and standard deviation sigma divided by the square root of n. Note that in order for the sampling distribution to be normal for any size n, the population must be normal to begin with. So to summarize, if the population is normally distributed, then the sampling distribution of x bar is also normally distributed for any sample size n. Now, if the population is not normally distributed? So this time, the population parameter has any distribution, mean mu and standard deviation sigma. This distribution could be skewed or bimodal or any other erratic shape. Random samples with a large sample size n and calculate all of the sample means, and once again put all of those sample means together, we get the sampling distribution of x bar. This distribution is approximately distributed with mean mu and standard deviation sigma divided by the square root of n. Note, this time I have written approximately normally distributed. As distribution simulation, as my sample size increased, sampling distribution came closer and closer to a normal distribution. Sample size need to be? The general rule is that n must be greater than or equal to 30 in order for the sampling distribution of x bar to be well approximated by a normal curve, regardless of the population distribution. It's one of the most important concepts in all of statistics, so it definitely deserves a slide of its own. The concept is called the central limit theorem. Here it is in formal terms. Suppose a random sample of size n is taken from any population. If the sample size n is sufficiently large, generally we say n greater than or equal to 30, and the sampling distribution of x bar is approximately normally distributed regardless of the underlying population distribution. We will use this theorem extensively throughout the remainder of the course, so make sure you take the time now to really understand what it is saying.
Right.
Okay.
All right. So the vocabulary review, we kind of like she already mentioned about the population statistics. We'll let you watch this vocabulary review on your own time. Let's take a look at example number 1. Here's example number 1. This is, I think, similar to your problems in the homework. Alright, may
A population of values has a normal distribution with mean 30.6 and standard deviation 46.8. You intend to draw a random sample of size n equals 38. What is the mean of the distribution of sample means? Well, according to the formulas that we learned about here, the mean of a group of sample means is simply equal to the population mean. So nothing changes when you're doing the mean of a group of sample means. The result is still 30.6.
So it's always the same. So the mean of the sample mean is the same thing with the mean. So it's always equal.
What is the standard deviation of this distribution of sample means? When you move to a sampling distribution for sample means, that does get affected for the standard deviation. The standard deviation of a group of sample means is equal to the overall population standard deviation divided by the square root of the sample size. So in this case, this would be 46.8 divided by the square root of 38. And we can use our calculator to approximate that. The 46.8 divided by second square gives me the square root. Divided by the square root of 38, that is 7.592. And just follow any rounding rules provided in the problem.
Pretty straightforward.
Yes.
Population of values.
Next example, this is another example. I'm gonna put this link in our homework and in Blackboard as well.
Let x represent the full length of a certain species of newt. Assume that x has a normal probability distribution with mean 191 inches and standard deviation 4.5 inches. We intend to measure a random sample of n equals 24 newts. The middle curve below represents the distribution of these sample means. The scale on the horizontal axis is the standard error of the sampling distribution. Complete the indicated boxes correct to 2 decimal places. Well, the boxes didn't show here, but effectively what we want to do is identify values along the x-axis. So I'll just choose a few of them to enter so that we can get started. Now, what we need to do is we need to find the mean and the standard deviation of this normal distribution. So that was provided as having a mean of 191 inches with a standard deviation of 4.5 inches. Now, this isn't the mean and standard deviation of the sampling distribution. The mean and standard deviation of the sampling distribution changes depending on what size sample you have. So the mean of a sampling distribution for the mean, it is just equal to the mean of your population. So it's still 191 inches. The standard deviation of your sampling distribution for the mean is the original population standard deviation divided by the square root of the sample size. So we put that into the calculator, we get an approximation of 5 divided by the square root of 24 comes up to 0.92. And I'm just going to use 2 decimals, but follow any rounding rules that are given in your problem. Now, to label the axis is still measured in inches. The mean is still located right in the center, whether we have a sampling distribution for the mean or if we just have the population, which is normal. Because both things are normal distributions. So the mean is, in this case, the mean of the sampling distribution, which is 191. Now, if we start going out from the mean, one standard deviation to the right or one standard deviation to the left, we just our new standard deviation or subtract our new standard deviation. So using the calculator, if I take 191 minus 0.92 and 191 plus 0.92, then 190.08, and I'm going to get rid of my box so I have a little bit more room to write. 190, 190.08, that one's that way, and 191.92 this way. If we continue another standard deviation, we just simply add 0.92 to that value to go another standard deviation, so 192.84. And we could continue this process any number of standard deviations. The same for going to the left. If I then take 190.08 minus another standard deviation, that puts me 9.16. Let x represent
Example number 3 is going to be similar again to your homework. I'm going to let you watch it on your own time while you're doing your homework, all right? Your homework this week is not as hard as last week. I know. Also, supposed to be we have a test this week, so we'll cancel that test number 2 and just do that next week. So what you're working on for this week is homework for week 9 and project number. All right.
Say that again, please.
So your homework for this week is homework for week 9, and you can start project number 3, which is already in your Blackboard.
Okay.
Number 2 will be next week, so we moved that because I figured it's a lot to do it this week, so moving it. All right. Notification. Any concerns?
No, I don't have any questions.
Yes.
I don't have any.
What?
Sorry, I don't have any questions.
Oh, I thought you guys were. All right, that's good. Thank you for coming. All right,
Well, thank you for explaining it. That definitely helped a lot.
that's good. If ever you'll be lost again when you're trying to do your own problem, you just text me or send me a picture, and then I'll get back to you as soon as possible. Okay?
Okay, thank you so much.
All right, you're welcome.
Have a good night.
All right, you too. Thanks. Oh, Nick is still there. Nick, probably harder assignments so that people will start coming in.
I think it might help those that definitely being able to talk to you and see you work through a problem.
Yeah.
What I experienced with that I had was, I guess, looking at it from a different aspect and working it backwards, which you're able to show us.
Mhm.
Some of the videos didn't really much insight that you were able to show.
Yeah,
Working.
I was trying to like also ask the other teachers who already taught this before in the campus, and they said is really the resources is limited for this particular one, so that's why I figured I have to include this in today's session.
No, I got you. And then it definitely helps knowing how to enter it into the calculator for those that need it.
Oh yeah, the inverse norm.
Exactly. If you're using the wrong together, you're not going to get the information that you should be getting.
Yeah,
So it definitely helped out you.
that's good. Appreciate you being here too. All right.
I'm always happy to be here and be a maybe somehow.
Wait. What course are you finishing? What degree?
I want to be a teacher. I want to be a math teacher.
Look at you, math teacher. If you
Huh?
were, huh?
What'd you say?
Uh, that's great. Are you planning to teach in Frederick or somewhere else?
I'd like to teach in Frederick County if I can.
No. No, Montgomery County, they're always looking for math teachers.
I know they are. I know they pay better in Montgomery County as well.
Yeah. Just let me know if you can't find like a position. I think they're always looking for math teachers in my school. You never know.
I want to teach middle school too, and I always
Are you sure?
yeah, see ya. Middle school math, believe it or not, yes.
Why? Like what? God.
Uh, Important time for children, and I also want to be an advocate for the kids. Like for
Understand.
those who don't have, I want to be a role model for them as well, showing them not only females can be teachers.
Yeah, I like that. That because my experience in middle school is not that great because I was in Baltimore City. So
Okay, that's yeah.
I'm not gonna teach any middle school anymore.
What grade level do you teach now at Montgomery County?
Montgomery, I have like a range of from 9 to 12 because
Okay,
some are
so all levels of high school.
yeah because some are like they're taking advanced math and taking just the on level courses. I teach pre-calculus and algebra too. So
Okay.
yeah, so if you're ready to look for positions and you can find one, I think our department is always looking for one.
Okay, so I'll be happy to keep you in mind.
All right, sounds good.
All right, well, have a good week.
Too enjoy your homework.
I will now that I know how to finish it.
Not that long. This week's homework not that long because I figured it's gonna be like a lot, that previous week.
Okay. This week going to be on the test next week or no?
This one, no, it's gonna be chapters 5 through 7.
Okay.
So it's all right. Enjoy the rest of your week, night. Have a great week. All right.
Thanks, you too.
All right.
All right, take care.
All right. You. Thanks.